Dear students, now today we are going to discuss about scalar and vector field. Let us look what do you mean by scalar and vector field. A variable quantity whose value at any point in a region of space depend upon the position of the point is called a point function. There are two types of the point function. First is scalar point function and another is vector point function. Let us look the scalar point function. Let capital R be a region of space at each point of which a scalar phi is equal to phi of xyz is given. Then phi is called a scalar function and capital R is called a scalar field. For example, time takes to complete a task is a scalar quantity because it is just a number with no other special attribute. Okay. While that, what is the meaning of vector point function? Let R be a region of space, if any region of the space, at each point of which a vector v is equal to at any point, means that is position, that is x, y, z is given, then v is called a vector point function and R is called a vector field. For example, like we always say, this velocity, the velocity of a moving fluid, velocity of a moving fluid. Okay, moving fluid. It means this has a unit direction, a special direction, moving fluid at any instant. Okay, the gravitational force are example of a vector point function. Okay, now derivative of a vector function with respect to a scalar. So for that purpose, let us consider R is equal to f t be a vector function of the scalar variable t. Let del t be a small increment in t and del r be the corresponding increment in r. You already gone through your school level. Again, we are repeating only. Then vector r plus vector del r is equal to f of t plus del t. So that del r is equal to f of t plus del t minus ft. Then what is this ratio? Del r by del t is equal to f of t plus del t minus ft by del t. So limiting value limit del t tends to 0, del r by del t is equal to limit del t tends to 0, f of t plus del t minus ft divided by del t. This exists. Then the value of this limit is denoted by dr by dt and it is called the derivative of r with respect to t. Okay. Now, what is the general rule for differentiation? Although you know and many rules are the similar, but we have to remember because vector calculus we are going to study first time. So d by dt of vector a plus minus vector b, this will be distributed dA by dt plus minus dB by dt. D by dt of a dot b, that is the similar product of two functions, dA by dt dot vector b plus vector a dot dB by dt. D by dt of vector a cross vector b, you must remember this, the vector a cross dB by dt plus dA cross dA by dt cross b, vector b. D by dt of phi of vector a, phi is scalar, then phi of dA by dt plus d phi by dt into a. D by dt of ABC, this is vector triple product. You can write like this, dA by dt, b, c plus a, dB by dt, c plus a dot b and dc by dt. Our cross product is already you know dA by dt cross vector b cross vector c plus vector a cross dB by dt cross vector c, okay, plus a vector a cross in bracket vector b cross dc by dt. So these are the general rules. Now, a derivative of a vector function in terms of its component. Let R be a constant function of the scalar variable t, and of course, this is the equation of the plane. You know, T vector R is equal to xi plus yj plus zk, where the component x, y, z are scalar function of t. Then dr by dt you may write like this. This is dx by dt vector I plus dy over dt vector j plus dz by dt vector k. Since di by dt is equal to dj by dt is equal to dk by dt is 0, therefore, if this is 0, then if ft has a constant magnitude, then you have to remember vector f dot df by dt is 0. If ft has a constant direction, then cross product means vector f cross df by dt is 0. If the scalar variable t denote the time and r is the position vector of a moving particle, then velocity is limit del t tends to 0 del r by del t is equal to dr by dt. And its direction along the tangent, that is vector a is equal to limit del t tends to 0 del v by del t is equal to dv by dt, and this is same as d2r by dt square. Okay, now let us look one problem. If R is a unit vector in the direction of vector R, then prove that vector R cross dr by dt is equal to vector R small r divided by R square into dr by dt, where small r is equal to modulus of this R. So how you will do? You know this relation. Then from here you can write this relation, and dr by dt you can write like this, and then R cross, taking cross the elementary cross result, you will find this. Already we discussed about the triple product, cross product also. Then you will get this value R vector R divided by R square cross dr by dt.